Hello and welcome back to Compiler Programming. Today we are going to be working on this issue I created just a bit ago. And basically what I realized is that currently this inline machine code bytes intrinsic is actually redundant to general intrinsic functionality in the compiler. I've added that quite early in the compiler so that I could do theoretically stuff like this. Let me find a test, right? So I could just put bytes in here, and then this is what the compiler will put in the binary, and then you could just put arbitrary stuff into the binary, which is pretty cool in a sense. But also, even at the point where I did it, I realized that it was very limiting to provide it this way. Like, it's unclear how to interact with labels. Like, I had to hack together the label support. It doesn't interact with the return values, right? So there is no real way to specify what this thing returns, if it returns anything. So in general, it's like it's a wrong level of primitive, even though it provides, I think, the right functionality. So I do want to be able to do this, but the way that it's done, I think, is not great. And now that I have the support for intrinsic, there is just a better way to do it. So it's time to get rid of it. And I'm just gonna replace the debugger stuff with something new. So I use debugger in assert, so that's something we should be able to test once it's done. And let's just dive right in and see how it goes. Okay, so what would that look like? Well, we need an intrinsic. We will call it I can get rid of this stuff. And here, now that this is intrinsic, we can do this. I could change it so that you don't have to call the function, but I think it's perfectly fine if it is a function call. There is sort of no reason. It's a debug code anyway, so who cares if it has braces or doesn't have braces. Okay, but the question is, what does it accept? Well, it accepts nothing, right? So that's perfectly nice. That means that we probably will not need the meta stuff. And then we can go to the tests and just steal the lazy value stuff. This is a pretty big chunk of code. Again, I probably will want to abstract it at some point, but that's not the job at hand at the moment. So let's just deal with this stuff and get rid of all the quotes. Okay, I can also get rid of the /ends. This should make code runnable. Now, what is going on in here? The first thing is that so what happens when debugger runs? When I call this here, this function gets executed immediately at compile time. And body of the function is actually here. So we allocate a new value, and this is a lazy value. So what that means in the compiler terms is that, like, right now there are basically two passes, more or less. In the first pass, we go through all the functions, or like through functions that are actually used, and we kind of try to parse it into sort of an AST. It's not really an AST in the sense that it's not persistent. Like, there isn't really a tree that you can look at fully, but it's just a series of closures or lambdas, whatever you want to call them, over each of the nodes. So you can just try to force this node to get the value back, or if it's not needed, and it was side effect free. Like if I, like for example, I know that I think assignments or something like this, or no, variable definition nodes are technically side effect free. So if I have something like foo is I don't know, I64, right? Just by itself, as long as foo is not referenced, this doesn't do anything. So this node will not even be forced and will not be part of the output. So anyway, so this was the first pass where you just go through this. But then the second pass, we actually, when we are forcing those nodes, we are also generating the action code. And this is what happens inside of this function. And this is where we would need to generate our CC instruction. So first of all, here we need to do something like this. So let's say void pointer. This I still need to take care of this type, so this more readable. Okay, so we have this void, and actually let's not call it void pointer. Let's just do type of void. And here, let's just do it like this. I like this more. Okay, so descriptor is void. Source range, that's fine. It doesn't have a structure, so this stuff is okay. We allocate lazy value descriptor. Yes, that's also fine. Lazy value proc, that's also okay. Technically, don't need to extract it like this. I can just do it in line, but I think it's actually more readable to put it separately. Okay, argument source range. All of that technically seems fine, but we will not actually get debugger. So first of all, I'll have to disable these tests, or more like bye-bye. These tests no more. They don't exist because this functionality does not exist. But we could have a disabled test in here. And we can say something along the lines of, actually this will probably not get us in debugger. Let's see. Assert false, oops. So this will be always disabled test, because if you actually try to run it, it will, crash your compiler. So that's not something I can do. I think I will need to restructure how I run tests in general and make it so that they run from the outside, not from the inside, and you just look at the output of the program rather than at some particular data structures. But anyhow, this is not related to work at hand. So for now, I'm just interested that if I do this test should actually, I think, pass now, but it shouldn't, because it should cause a debugger. Yeah. Okay, great. So what that actually means that this code executed just fine, and we ran this, but because we are not generating the right instruction, nothing actually happens. Okay, so this is the time for us to go in here and start exporting some types. Export this stuff. We need an instruction. This is going to be instruction byte. What else do we need? I guess we will also need to something like push eagerly encoded assembly or something. Yes, we probably want to expose this function to the outside world. So let's do that. It's getting a bit messy in here, so maybe I should figure out if there is a better way to organize this, but for now, again, it's okay. Just need to make progress. Okay. This is no, that's not gonna work. Damn it. Wanted to do some fancy multi-line editing, but that's actually not gonna work pretty well, so I guess manual it is. And you also need to be in braces. Great. So you take here, you take here. You don't return anything, I believe. Right, you don't. And we are good, I think. We copy pasted the wrong thing. Oh no, type function. Yeah, everything is fine. So what's the issue exactly? This is here, this is here. Ah, I forgot the commas. The okay. So that seems fine. Now this function should be accessible to us outside. And do we need anything else? I guess not. So let's just say that code block. Oh, we don't actually need this. So mass push eagerly. Is it good? No, that's not push eagerly encoded assembly. That's not what I want. I want push instruction, I guess. So yeah, I do want push instruction. So I pushed the wrong thing. That's fine. Okay. Now we need to turn this code into something that our language can understand. So we say instruction is, well, just like this. Oh, damn it. Trying mixing two languages is always a bit of a nightmare, but it is fine. Now, one of the problems I actually do have is that this is not gonna be zero initialized, although it's actually, no, it's actually completely irrelevant. That's not zero initialized. Okay, that's fine. So tag is this instruction tag bytes, and then instruction bytes memory is 0 is 0xcc, and instruction bytes memory length is 1. So hopefully that is going to do the trick, but we'll see. Now we need to go back here, and I actually need to change this and say instruction. Okay. This operation is going to be very slow right now in the compiler because there is another bug that I opened that happens with unions, like we copy them too much, but that should not affect the functionality of the thing. So that's fine. Direction. Wait. You'll push it, right? Okay. That is that, I guess. Technically, we also need to push a source range somewhere in here. Where are you? Yes. This stuff. Now I'll just do this because that's not really important for the functionality, but it will be important later on for debugging. Actually, in a sense, it is important for debugging because in assertion we will not see the right thing, but okay, whatever. Let's run a test and see if I screw this up somewhere. Okay, so this doesn't do anything, but I'm still not 100% sure that it will work anyway before. So what I will do instead is I will say static assert, because static assert actually calls assert at compile time. I think. No, it doesn't. So how do I test this? I guess like foo is a compile time function, and then I will just do something like that. Let's try that. Okay, so we crashed, which is not cool. Question is, what did I screw up? Let's run the test and see. Maybe it is just not handling it correctly. Disable this breakpoint. Integer division by 0. Yikesy. Yeah, okay. That's a different problem that I need to fix. Has nothing to do with what we're doing right now. So let's just postpone this thing. It's not cool that we did not do anything. I would expect something to happen. Let's try back this stuff. So we say that that's a void and a void. Let's put this back in here. And we are going to call checker. And actually, we're also gonna verify that it compiled fine, because I think that's now the problem, that it doesn't actually compile. Yeah. So here It's all about the prefix. Let's try again. Right-hand side of a parameter of an array must be expression. Right, it's not memory. It's length. Just without it. Did not find acceptable encoding. Why were you even trying to find encoding? That is the question. Okay. I'm confused. Who calls you? We're trying to move a value, we're trying to assign target descriptor is U815. I think I know what's going on. I don't handle this case anywhere. Where we are trying to assign a fixed array to fixed array, right? That's what is happening. Target is a fixed array and source is fixed array. Okay. I don't think it's handled in the here. So what does move value do? It looks at this stuff, blah, blah, blah. At some point I had this rep move, but I removed it because I wanted to do it manually, right? So we do need to go to assign and here and deal with this stuff. So there is somewhere in here, yes, this thing for structs, where we iterate for each struct. And now we need to have a similar thing for fixed arrays. Fixed size array. If we cannot do that, that's fine. So I think in here it even needs to be the same type. We'll see if that's correct. But for now, so what should it generate? That's an interesting question. Probably rep move, but I'm very lazy at the moment, so we're just gonna do this. It's just gonna be nasty, but it is fine. So how would that look like? We need the descriptor here. Actually, like this: source descriptor fixed size array length or something. Does it compile? No. It is length. Right. You don't need the extra length around it. Target descriptor, source descriptor. That should be okay. And now we need to generate operands. How would that work? So load index or something? Index? Okay, dot operator. What are we doing here? Are we dealing with the arrays? Struct field access, struct field access. Alright, handle array access. Fine. So that is a bit awkward. Okay, I'm just not gonna think about the effectiveness of this code, I guess. And we are just gonna do some weird stuff. Actually, not really. I think for the right semantics, we need to, yeah, we do need to generate element by element copies, because otherwise we will not extract like static elements and such. So we need to essentially do the same thing here, except storage is going to be different, right? What is going to be the storage? Can I just call this stuff and not worry about it? Maybe the reference, storage interact. I mean, I guess I can. I might have to add this to the headers. This is going to be very, very awkward. But that is okay. Do I want to split this up? No, I think I do want to split this up. This is a bit too much even for me. Okay, this is already checked, even by size, that's fine. So, okay, so this is not as bad as I thought. We can take this code because we do know the index, right? Okay, number. Is this like U64 to S32 of I? Yes, we will not be able to copy large arrays. I don't care at the moment. Index number, offset, item byte size. So we need to have descriptor, item descriptor is source descriptor, fixed size array, item or something. Okay. And then we create offset, we maybe do reference source. So this is like a source array storage, and that we can do outside of this code, right? And we don't copy the flags. So this is like source item storage. And then we would need to have, oh, I can do this here. Then this goes here, and this would be targets array storage. This is going to be incredibly inefficient, but that's okay. We do the same with the target. Okay. And then after we are done, we will need to free the storage. Release if temporary, builder, source array storage, and target array storage. Something along these lines. Descriptor. Okay, let's see what happens here. Const descriptor, not descriptor. Value may be the reference, that's okay. We just need to forward declare it. Haven't here. All right, I accidentally deleted a bit of code which I need to restore. Okay. Now let's get back over here where we were. Function instance, struct. What? Damn it. Just want this code. What is going on here? I think I accidentally saved there and then it causes issues. Here again. Is this fine? Okay, yes, that's what I want. That was just strange. Const storage. Yeah. I don't need any of that stuff. Okay, item byte size. So item descriptor, bit size. Actually, I have this stuff. Descriptor, byte size. So Okay, we are building, I think. Great. So that was a bit of a detour here, but let's see if that actually helps us. We can run this. Did not find acceptable. Right. I forgot to stop this. Let's try again. That's actually what we want. That is correct behavior. We got our int3, which is the code cc, so that means that our assertion actually did what's supposed to. It printed oops, and it stopped at this rate. So everything is working as it should. There's definitely stuff to improve over here, like that's not great code by any stretch of the imagination, but it does work. We can try to push the instruction here as well, but we'll see if that actually would work out fine. So we need to copy this. We need to say that this is source range, and then location, source range is source range star. It's actually called location. And let's see if that works. There should be no visible difference between those two. But apparently there is. Build tag does not exist in type overload set. All right. Great. And we can try to do BT. And is that even correct? It doesn't seem like a proper backtrace, so we need to look into that. But that's sort of, again, not our point at the moment. Anyhow, so things are working. I'm very happy with how it turned out, and it looks like I didn't use fixed size arrays enough to trigger even some basic copying, which was also good to clean up. I need to figure out how to shorten this code. Obviously that's not scalable. Even C version is much simpler, but the most important thing, it does work. It allows us to get rid of the inline machine code bytes. So let's actually do that. I can say git add, and we say, actually, let's disable this test and run all the tests to make sure I didn't screw up anything else. I didn't. Now we can go in and do the nice part of the any coding, removing code. This stuff all goes away. Also in here, it also goes away. Tadik, let's see that we are still working. We are, and that is that. I'm super excited to clean up even more inside the compiler because there is some internals that were required for inline machine code bytes to work that now can also be cleared out. But for this video, that's all I wanted to do. I'm I'm really enjoying the fact that I have now this intrinsic support that allows me to write all kinds of code in the userland instead of it being in the compiler core, which should allow it to keep very simple inside. Okay, thank you very much for watching, and hopefully see you next time.